Hello, this is the section 8.5 lesson. In this section we're going to combine some ideas from earlier on in the semester with some ideas from sections 8.1 and 8.2 to talk about divisibility tests. Now these divisibility tests are probably something that you're already familiar with. You know how they work. What we want to talk about here is why they work. And one important idea that we're going to use to justify why these work is an idea from earlier on this semester called the distributive property. The distributive property said we start off with here a number A times another number B plus another number C, and then we can distribute that A across addition, and we get this expression here on the right hand side. Now we can use this distributive property in two ways. We can go from the left side to the right side, and when we do that we typically call that distribution. Sometimes we can go the other direction. If I have a sum like this on the right and I want to factor out an A, I can do that, and when we do this we call it factoring. In this section we're going to use this idea of factoring to justify these divisibility tests. So our first divisibility test is going to be a test for divisibility by 2. And so to illustrate why this test works, let's look at this simple example. Is the number 946 divisible by 2? Well, there's lots of ways that we could restate this question. One way to restate it is like this. Is 946 divided by 2 a whole number? That's just going back to the definition of divisibility. Well, now let's restate this in a third way using the connection between division and multiplication, and state it, is 946 equal to 2 times n for some whole number n? Now where does this idea come from? Well, let's take this second expression here and rewrite it like this. 946 divided by 2, does that equal a whole number? So let's give that number a name. Let's call it n. And so now if we rewrite this, we can multiply both sides by 2 to get 946 equals 2 times n. And that's just exactly what we have here in this third expression. And so those two ideas really are equivalent. So let's work with this third idea to try to answer this question, is 946 divisible by 2? And we're going to take a little bit of an algebraic approach here to answer this question, is 946 equal to 2 times n for some whole number n? And so we're going to start off here, we're going to take the number 946 and we're going to write it as the number 940 plus 6. Now, why can I do that? Well, because if I add 940 and 6, I really do get 946. Now, why do I do it? Well, just stick with me. You'll see why we do it. Now, the next step, we're going to take this number 940 and write it as 10 times 94. Now, why can I do that? Well, if I take 10 times 94, I really do get 940. Now, in our third step, we're going to factor things a little bit. So we're going to take this 10 and write it as 2 times 5, and then we're going to write this 6 as 2 times 3. Well, now why would I do that? Well, because now look what we have here. We've got this term here plus this term here, and both of these terms have a factor of 2. And so we can factor that 2 out to get this expression right here. Well, what's significant about that is here we have 2 times, and then this quantity in parentheses, well, this is a whole number. Now, I could do that arithmetic and figure out exactly what whole number that is, but I'm not terribly interested in the exact value of that number. All I care is that it's a whole number. And so look at what we were able to do. We were able to write the number 946 as 2 times a whole number. And so we can answer our question as yes. 946 is equal to 2 times n for some whole number. So that means that 946 is indeed divisible by 2. Well, let's look at a similar example, and we're going to make some comparisons here to motivate our divisibility tests for 2. So question, is the number 35 divisible by 2? Well, let's rewrite this in a couple of equivalent ways. Is 35 divided by 2 a whole number, or equivalently is 35 equal to 2 times n for some whole number? So same basic ways of rewriting as in the previous example, and again we're going to work with this third way of asking the question to try to answer it. So let's rewrite this in the same basic way as what we did in the previous example. Let's take 35 and write it as 30 plus 5. And then let's factor the 30 as 10 times 3. And then let's factor the 10 as 2 times 5. So now my goal here, just like in the previous problem, was to write this as 2 times some whole number. What we have here is a whole number plus a whole number. This first whole number has a factor of 2. But this second number I can't write as 2 times some whole number. So we have no factor of 2. And so I cannot factor a 2 out of this right-hand side. And so now we can answer our question. Is 35 equal to 2 times n for some whole number? The answer is no, it's not. So 35 is not divisible by 2. Well, let's do a little compare and contrast here. So in our first example, we wrote 946 as 940 plus 6. We were able to factor a 2 out of that first term and a 2 out of the second term. And so we were able to factor a 2 out of both terms, and we concluded that 946 was indeed divisible by 2. In the 35, we wrote it as 30 plus 5. We're able to factor a 2 out of the first term, but not the second term. And so because we weren't able to factor a 2 out of that second term, this number was not divisible by 2. And so in the end, all that really mattered was this last number here, the 6 or the 5. The 6 we were able to factor a 2 out of, the 5 we were not. And so all that matters is the ones digit. The first digits in the number, the 94 or the 3, those just didn't matter. All that mattered was the ones digit. If we're able to factor a 2 out of that ones digit, then we're able to factor a 2 out of the whole number. So that leads us to our divisibility test for 2, which says that if the ones digit is 0, 2, 4, 6, or 8, and all those numbers are divisible by 2, then the overall number is divisible by 2. Otherwise, the number is not divisible by 2. So again, all that matters is the ones digit. And the reason that the ones digit is all that matters is because of the distributive property. So let's look at another example to motivate another divisibility test. Is the number 426 divisible by 10? Well, let's rewrite that in a couple equivalent ways. Again, the first way is 946 divided by 10, a whole number, which is equivalent to saying is 426 equal to 10 times some n for some whole number n. Well, let's stop right there and just look at this right-hand side, the 10 times n. What we have is 10 times a whole number. We know from earlier on this semester that if we take 10 times a whole number, this number is going to end in a 0. It doesn't matter what the number n is, because it's a whole number, we know that 10 times n is going to end in a 0. But now if we look at this right-hand side, or left-hand side, the 426, that does not end in 0. So there's no 0 at the end of that number. So on the left we have a number that does not end in 0. On the right we do have a number that ends in 0. Well, this can't happen. They can't be equal. And so there we have the answer to our question. Is 426 equal to 10 times n for some whole number? The answer is no. So that means that the number 426 is not divisible by 10. So again, we see that all that really mattered was the last digit. And so that motivates our divisibility test for 10. If the ones digit is 0, then the number is divisible by 10. Otherwise, the number is not divisible by 10. All we've got to do is look at the ones digit. Now, to motivate our last divisibility test that we'll talk about in this lesson, let's look at this example. Is the number 23 divisible by 3? Which is equivalent to the question, is 23 divided by 3 a whole number? Now, we could convert this to an equivalent expression involving multiplication, but we're not going to do that. Instead, we're going to interpret this a little bit differently. Let's interpret it in this way. Can we divide 23 popsicle sticks evenly among 3 cups? So we're going to go back to this idea of popsicle sticks and cups that we used earlier on in the semester. And so let's draw a picture of this. I'm going to start off with 3 cups here at the bottom. Now we've got 23 popsicle sticks. So let's represent this with 2 boxes that represent 10 popsicle sticks each. And then we're going to have 3 popsicle sticks, 3 individual popsicle sticks. So you want to divide these popsicle sticks among the 3 cups. So I start off with my biggest bundles, meaning these bundles of 10 here. I can't distribute them evenly, and so let's unbundle them. I'm going to take this first bundle and break it up into 10 individual popsicle sticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're also going to unbundle the second bundle of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there we've unbundled that second bundle. Now this may seem a little bit different than what we did earlier on in the semester, but just stick with me, you'll see where we're going with this. Okay? So now we've got a whole bunch of individual popsicle sticks, and so let's distribute these among the 3 cups. So let's take 3 popsicle sticks, or let's put 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So I've got rid of 9 of those popsicle sticks from the first bundle of 10. Now let's do the same with the second bundle. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's stop here and make an observation. So I've got 2 popsicle sticks left right here from those bundles of 10, and then I've got another 3 individual popsicle sticks left from my ones digit. So what we have is 2 plus 3 popsicle sticks left. Okay? And that of course equals 5 popsicle sticks. So now I ask myself, can I divide those popsicle sticks evenly among my 3 cups? Well, no, I'm not going to be able to divide all of those among my cups. So I can't divide all of them evenly. So can't divide all 5 evenly. I could get rid of 3 more and then have 2 left, but I'm still not going to be able to do anything with those last 2. And so I can't divide all of these popsicle sticks evenly among the cups. So let's take a step back and talk about what's the main point of this. So the number of popsicle sticks left is equal to the sum of the digits. We had 2 left over from the 2 bundles of 10, and then we had 3 left over from the 3 individual popsicle sticks. And so since the sum of this digits, which was 5, is not divisible by 3, then the number 23 is not divisible by 3. So it all boiled down to the sum of the digits. We had 2 left over from those 2 bundles of 10, 3 left over from the 3 individual popsicle sticks. That was not divisible by 3, and so we concluded that the overall number 23 is not divisible by 3. And so here all that mattered was the sum of the digits. And so this leads to our divisibility test for 3, which says that we add the digits of the number. If the sum of the digits is divisible by 3, then the original number is also divisible by 3. Otherwise, the number is not divisible by 3. So here we go. We've talked about 3 different divisibility tests. We use some algebraic arguments to justify the first 2 divisibility tests, and we use some pictures to justify the third test. So I hope you see how these ideas from earlier on this semester can be used to talk about ideas from number theory.